You're listening to This Week in Cardiology from theheart.org on Medscape.
You can now access the latest in medical news on your Amazon Alexa-enabled device. Join me, Perry Wilson, every weekday morning for Medscape Medical Minute, where I highlight the top medical stories of the day. To add Medscape Medical Minute to your flash briefing, search for Medscape Medical Minute on Amazon and click Enable. Or open the Amazon Alexa app, go to Skills, search for Medscape Medical Minute, and click Enable. Then say, Alexa, what's the news? Or, Alexa, what's my flash briefing? I hope you'll join us.
Hi everyone, this is John Mandrola from theheart.org Medscape Cardiology, and this is This Week in Cardiology for June 5th, 2020. This week, COVID, Justice, Impella, XL, Lord Bays, and retractions. First, a brief update on COVID. When I recorded last week, there were 1.75 million cases in the U.S. Today, 1.9 million. The rate of growth of 1.08x is about the same as last week. U.S. deaths last week were 102,000, and this week they are 109,000. The rate of rise is identical at 1.06x. Now, this is a cardiology podcast, and I will discuss cardiology topics today, but it seems tone deaf and irreverent to drone on without acknowledging the widespread protest about racial injustice. I am a white male who is raised with every advantage one could have. Stable family, enough money, but not too much money, Italian grandparents close by, schools, and dedicated teachers. Now, that latter point about mentors is super important. I am an electrophysiologist because of mentors. It's impossible for people like me to feel the injustices felt by racial minorities. My friend, Dr. Andrew Foy, is a cardiologist and researcher in Hershey, Pennsylvania. He has a unique point of view of the Black and Hispanic communities because he promotes boxing. Andrew sent me a slide he made and posted on social media showing the percentage of Black and Hispanic graduates of medical school versus the percentage of Blacks and Hispanics in the U.S. population. And it showed that the percentage of Black and Hispanic U.S. medical graduates is 11%, but the percent in the population is 32%. Andrew's point is that medical education leaders are not doing enough to close the gap, and here's what he wrote. He strongly believes the social capital created by having more Black as well as Hispanic physicians would be immeasurable for urban, underserved communities, and it would have a large impact on reducing health disparities in this country. I will link to his entire post. It's worth a look, but advocacy for more Black and Hispanic doctors is something I can get behind. Now to cardiology. First up, Impella. The FDA issued an emergency use authorization for Impella RP for COVID patients with right heart failure. This is classic COVID-19 science, which is not a good thing. Here's a quote from the FDA letter. Based on the extrapolation of data from the approved indication and reported clinical experience, the FDA has concluded that Impella may be effective at providing temporary RV support for the treatment of acute right heart failure caused by COVID-19 complications, including pulmonary embolism. Now, I've previously discussed on this podcast the lack of RCT-level data in support of the approved indication for Impella, but let's today focus on the above-noted, quote, reported clinical experience. One is a case report, a 59-year-old female with COVID and RV failure due to acute PE. She survived after placement of an Impella. The same group has also reported in 2018 a series of 5 patients with acute PE and right heart failure treated with the ECOS endovascular system, which is low-intensity ultrasound for the purpose of facilitated thrombolysis using low-dose fibrinolytic therapy. In this series of 5 patients, all patients survived, but the endpoints of the case were hemodynamic measures. So there has to be more than a single case in a 2-year-old case series of 5 patients. Well, there is. And get this. Other data cited in support of the Impella RP emergency use authorization included a link to an attempted systematic review from Japanese authors who wrote this in the abstract. Quote, The results evidence that available data are currently scant to definitively assess the real role of Impella RP in patients with PE and refractory shock. So data like this makes some of the crazy COVID-19 science actually look good. A couple of case reports, an old case series without a control group, and one that reports only hemodynamic measures. What's more, I talked to two of our PE interventionalists here at my hospital. Both said, John, think about it. What sense does RV support make in acute PE? You help bypass the failing RV by dumping more blood into the PA, which is occluded with clot. Their choice of hemodynamic support in PE is ECMO, which supports both the hemodynamic and oxygenation issues. The thing that baffles me is we could easily have an answer with mechanical circulatory support. FDA or CMS simply could say, if you want reimbursement for this device, do it as part of an adaptive RCT. If it is good as people think, this would be a very small trial. They could say, in the meantime, you can use this device, fine, but go ahead, we're not paying. Second topic today deals with coronary artery disease, and again, JAMA Internal Medicine provides some really beautiful papers on this topic. I'll link to these. Now, first is a meta-research paper looking at RCTs in interventional and structural cardiology from 2008 to 2019. The authors, led by academic heart surgeon Mario Gaudino, studied the association between trial design and outcome and reporting with industry funding. They found that about half the trials had industry sponsors. Surprisingly, only about half used hard endpoints. Also typical of cardiac RCTs, the mean follow-up was short at 1 year. Almost 1 in 5 of these trials were not prospectively registered, which is bad. They also found one major discrepancy existed between the registered and published outcomes. This was in 38% of papers. That's also bad. Commercial sponsorship was associated with a statistically significant finding favoring the sponsored treatment, 64% versus 49% with a significant p-value. Spin, which I've published on before, is language that detracts from a non-significant primary endpoint, was present in 65% of trials. And it was significantly more likely in industry-sponsored trials, 80% versus 54%, which also met clinical significance. My friends, this sort of meta-research is not minutia. It is important in the translation of medical evidence at the bedside. Remember David Sackett's 3 circles of EBM, best evidence, plus clinical judgment, plus patient values. Crucial in that mix is the ability to appraise the evidence. And part of appraisal is using priors, such as the role of spin and industry funding in the design and reporting of trials. Okay, speaking of using priors, now to the main entree of the JAMA Internal Medicine series of papers. This is a relook at the XL trial, a Bayesian reanalysis of XL, which was an RCT comparing left main PCI versus CABG in patients with suitable anatomy. Before you get twisted out of sorts about the complexities of the word Bayesian, let's first set out how basic this is. I watch my grandchildren learn. Children are natural Bayesians. They constantly use prior information to adjust their behavior. I will link to a nice Slate article which describes some experiments showing what all parents know. Doctors, too, are natural Bayesians. An example, if you get a positive stress test in a patient with fleeting, non-cardiac chest pain and no risk factors, your brain calculates that the probability is high that it is a false positive. And probabilities are key in Bayesian thinking. You don't think the stress test in this low-risk patient is 100% a false positive. You estimate something like an 80% chance that it is, because even low-risk patients can have disease. Adjusting beliefs based on information coming in is also paramount in Bayesian probabilities. Now let's get back to the low-risk stress test. You estimated the chance of a false positive was about 80%. But if I now tell you it was a nuclear stress test and the patient went 10 minutes and had no ECG changes, and the positive part was in the area where breast attenuation is often seen, you might bump up your probability of a false positive to something like 90 or 95%. But then an earnest medical student goes into the chart, finds an old nuclear stress test this patient had from 5 years ago at another hospital, and guess what? That test also showed a defect on the perfusion scan in the same area, and that patient at the time had a negative angiogram. So now with that prior information, you now up your probability to, say, a 99.9% chance. It's a false positive. Okay, to sum up, we have two aspects of Bayesian thinking. First, the use of prior information, and second, the adjustment of probabilities of something given the prior information. The other way Bayesian interpretation of trial results differ than the standard null hypothesis significance testing using p-values is that Bayesians estimate the probability of the hypothesis given the results, while we are much more used to the frequentist approach of estimating the probability of the results observed given the hypothesis. And that is, of course, usually no difference. For example, in the 5-year Excel results, the paper reported that in the primary endpoint, which was a composite of MACE, the difference was 2.8% higher for PCI. The confidence intervals ranged from a 0.9% reduction to a 6.5% increase in MACE, and the p-value was non-significant. So another way of saying non-significant is to say, given the null hypothesis that PCI and CABG were not different, the likelihood of finding this data was greater than a threshold of 0.05. And this non-significant difference led the authors to conclude that PCI and CABG perform equally well. And then that conclusion was codified in guidelines. The equivalence, however, was also problematic on its own because the odds ratio for the mortality signal was 38% higher in the PCI arm. Recall that the authors of Excel argued at the time that the mortality signal was a post hoc subgroup that was underpowered and was likely due to chance. Okay, now, Professor James Brophy from McGill University took the data from Excel and previous studies and did a Bayesian analysis. His results are highly notable not just for deciding on PCI or CABG in left main disease, but more importantly, for the interpretation of any clinical trial in cardiology. Let's leave aside the controversy over MI definition in Excel and just look at the data the way a natural learner like a Bayesian would. Brophy first took the Excel data on its own. You can call this a non-informative prior. He then took an effect size, in this case an increase in 1% mortality with PCI, and used the trial data to calculate its probability. Now, before you think a 1% increase in mortality is not that much, consider that we shut down the world's economy for a virus with a fatality rate significantly less than 1%. Brophy found that there was a 99% probability that total mortality for patients with left main coronary disease is increased with PCI, and a 94% probability that the increase exceeded 1%. He did the same for the primary endpoint of major adverse cardiac outcomes, and the corresponding probabilities here for any increase was 95%, and it was for being greater than 1% was 87%. And for major adverse cardiac and cerebral events, it was 99.9% and higher than 99% respectively. So then Brophy did the analysis again using the previous studies, a so-called informative prior. Here, for mortality, the probability that PCI increased mortality at all was 85%, and that it increased more than 1% was 47%. For MACE, the probability that PCI increased events over CABG was 96%, and that it increased it more than 1% was 86%. Now, one other point that both Brophy and editorialist Sanjay Kaul from Cedars-Sinai brought up that I think was under-recognized at the time was that the 3-year Excel results were analyzed as a non-inferiority design, and the non-inferiority margin was set at 4.2 percentage points. In other words, if PCI was worse than CABG, but the upper interval was less than 4.2, PCI could still be deemed non-inferior. And it was at 3 years, barely. But then the authors changed the analytic method at 5 years to superiority. And this is important because, as I told you, in the 5-year results, the 2.8% higher rate of MACE with PCI had an upper bound of 6%, which would have exceeded the non-inferiority margin. Thus, had the Excel authors stayed true to their analytic method, PCI would be deemed non-inferior to CABG. And these two reasons is why Brophy and Call conclude that for patients with left main, CABG is the better approach. Finally, I have seen people do Bayesian analysis of trials before, and I find them extremely useful from a clinical perspective, because that's how we think at the bedside. Take a look at this paper and the editorial. Once you see this stuff, it's hard to unsee it, and I hope that more trials get analyzed like this. Final topic today is the Lancet and New England Journal retraction that happened hours before I taped this podcast. I promised my editor that I would increase the ratio of cardiology to COVID news, but how can we ignore the fact that 2 of the highest medical journals retracted 2 major observational trials? The Lancet pulled the hydroxychloroquine observational study, the one that got great press and actually caused the WHO to pause the HCQ-RCT. And New England pulled a study from the same authors on underlying cardiovascular disease and increased risk of COVID. That study also did not find a harmful association of ACE inhibition or ARBs. 2 brief comments. Retraction of these papers can be directly attributable to sleuth-like investigations from people on Twitter and social media. Some of these people had content expertise, but others were just armed with curiosity. This highlights the extreme value of post-publication peer review. And I think it should send a warning to the whole healthcare journalism field that making conclusions from published papers, especially in the COVID space, is fraught. It might be best to wait a few days before splashing big headlines and strong leading paragraphs, and also following some key people on Twitter. Second comment, and I leave this to the end because I feel so strongly about it. Even if these papers were pristine, they were still non-randomized observational studies which should not be used to shred equipoise or make clinical decisions at the bedside. The reason is obvious. No matter the strength of the statistical adjustments, researchers can only adjust for the things that are on data spreadsheets. But any doctor knows that the decisions that we make have to do not just with tangible things you can put on spreadsheets, but intangible things that are not captured in big data. That fact leads to confounding biases in all observational trials. It's why, if you want to make causal inference, it's much better to make it from a double-blind, randomized, controlled trial. That's it for this week in cardiology. As always, I am grateful that you listened. Thank you. And remember, please, if you like this podcast, it really helps to give us a rating. A written review goes a long way. Tell your friends so that others can find us. Until next week, this is John Mandrola from the Heart.org Medscape Cardiology.
You're listening to This Week in Cardiology from the Heart.org on Medscape.